All right, so we want to mine asteroids,
Mine asteroids.
not just talk about it, but actually extract resources
Oh, wow.
from these chunks of rock hurtling through space.
Hurtling through space.
Sounds kind of like science fiction, right?
It might sound like it, but the reality is it's closer than you think.
Really?
Yeah. We've got our hands on a fascinating excerpt today,
Okay.
all about excavation methods in low-gravity environments.
Low gravity.
It's a glimpse into the future of space mining.
And it's not as simple as just bringing a shovel up there, is it?
No, not quite.
I can't imagine an astronaut bouncing around trying to dig a hole and their tools floating away.
You're not far off. Low gravity is one of the biggest hurdles.
I bet.
Traditional methods just won't work.
I can see that being a problem.
Imagine trying to walk on a giant bouncy castle.
Okay.
One wrong step and you're flying.
Yeah.
That's what it's like trying to operate heavy machinery on an asteroid.
So how do you even begin to tackle that?
Well,
Are we talking about some sort of space-age superglue for boots?
not quite. Engineers have come up with some incredibly ingenious solutions.
Okay.
One approach is anchoring.
Anchoring.
Think of robots with harpoons, drills, or clamps, almost like space spiders,
Well,
clinging onto the asteroid's surface to gain stability.
that's a pretty cool visual.
It is.
So you get a good grip before you start digging. But what about the actual digging part?
Right.
Is the asteroid surface like regular soil?
Not at all.
What is it like?
It's covered in this stuff called regolith,
Regolith.
which can be incredibly unpredictable.
Okay.
It's often loosely packed, and a small vibration could trigger a landslide.
Like an avalanche.
It's almost like trying to build a sandcastle on a trampoline.
So even if you manage to anchor yourself, you're still dealing with a very delicate and unstable surface.
Yes.
What kind of tools can even handle that?
There are several approaches being explored.
Like what?
One is pneumatic systems,
Pneumatic.
essentially giant space vacuums
So a giant cosmic vacuum cleaner.
that suck up loose regolith. It's particularly effective for collecting fine-grained material.
So you're not damaging anything.
Right.
That sounds pretty efficient,
Yeah,
especially if you're worried about delicate surfaces.
exactly. But vacuums alone won't cut it.
I can imagine.
For deeper excavation, we're looking at mechanical scooping and drilling.
Yeah.
Think robotic arms with specialized scoops and buckets.
Okay.
Or drills modified to work in low gravity.
I'm guessing those modifications are crucial.
They are.
Wouldn't a regular drill just send the whole robot spinning in circles?
Absolutely. That's why these systems often incorporate counter-rotating mechanisms
Rotating.
to counteract those forces and maintain stability.
Interesting.
It's all about precision and control in an environment where the slightest nudge can send you off course.
Now, I've heard about some even more unconventional approaches.
Oh, yeah.
This is where it gets really mind-blowing. Something about melting the asteroid.
That's right.
Really?
It's called thermal excavation.
Thermal excavation.
And it's particularly effective for asteroids rich in water ice.
Water ice.
Imagine using heat to melt the icy regolith and then collecting the liquid.
So you're talking about creating giant cosmic slushies.
It's surprisingly effective method.
Wow.
Especially for asteroids with large deposits of water ice. And there are even more fascinating techniques being explored,
Okay, what else is there?
like electrostatic and magnetic excavation.
Okay, hold on. Now we're talking about static cling and magnets in space.
Yeah.
How does that even work?
Well, electrostatic excavation utilizes charged surfaces to attract fine particles of regolith,
Okay.
almost like static cling,
Mm-hmm.
while magnetic separation uses magnets to extract metallic components.
So it's like we have a toolbox filled with gadgets straight out of a sci-fi movie.
Kind of.
Anchors, vacuums, drills, melting magnets.
Right.
Each challenge seems to require a completely different approach.
It's true. Each method has its own advantages and disadvantages. And choosing the right one depends on the specific characteristics of the asteroid and the desired resources.
Makes sense.
But even these incredibly innovative solutions are just the tip of the iceberg.
Wait, there's more. What could be even more futuristic than melting asteroids and space magnets?
Well, imagine swarms of tiny robots working together like ants to excavate vast areas.
Oh.
Or modular platforms equipped with interchangeable tools.
So like a Swiss Army knife of space excavation tools?
Exactly.
That's pretty cool.
And these future systems could be even more adaptable and efficient,
How so?
potentially incorporating artificial intelligence and automation.
Robots that can think for themselves,
Yeah.
learn from their environment, and make decisions on the fly.
It's a testament to human ingenuity,
It really is.
pushing the boundaries of what's possible in the quest for resources beyond Earth.
Now, with all these mind-boggling concepts, I have one very practical question.
Okay.
How on earth do scientists test these methods? Do they have a secret asteroid hidden away somewhere for test runs?
Not quite a secret asteroid,
Okay.
but they've devised some clever ways to simulate those challenging space conditions right here on Earth.
I'm all ears.
Yeah.
How do you recreate an asteroid on Earth?
One method involves parabolic flights,
Parabolic flights.
where they take equipment for a ride on a special aircraft nicknamed the Vomit Comet.
The Vomit Comet. That doesn't sound too pleasant.
It's not for the faint of heart.
Okay.
The aircraft flies in a specific parabolic arc, creating brief periods of weightlessness.
Oh, so they can test their gadgets in a zero-G environment for a short time.
Exactly.
Clever. And to recreate the airless vacuum of space, they use vacuum chambers.
Right.
This allows them to observe how tools behave without the effects of atmospheric pressure.
Precisely.
Right, because space is a vacuum and tools might behave differently without air around them. What about the asteroid surface itself? Do they build some kind of replica?
They do. They use something called regolith simulants.
Regolith simulants.
Earth materials carefully engineered to mimic the properties of asteroid surfaces.
So it's like a giant space sandbox for scientists,
Yeah.
where they can experiment and tinker to their heart's content.
It's a crucial step in ensuring that the tools and techniques are up to the task before sending them millions of miles away.
Absolutely.
Hmm.
And speaking of tools, there are some incredible robots being developed specifically for asteroid mining.
There are.
Tell me about these space-age mining robots. What are they capable of?
Well, there's NASA's RASOR,
RESOR.
short for Regolith Advanced Surface Systems Operations Robot.
It's a mouthful.
It's designed to scoot around on asteroids, digging and collecting regolith with its counter-rotating bucket drums.
So I'm guessing that counter-rotation is key to maintaining stability in that low-gravity environment.
Precisely. It prevents the robot from spinning out of control due to the reaction forces of digging.
Very cool. And then there's Planetary Resources ARCID spacecraft.
Yes.
So ARCID is more like a multi-purpose space mining machine,
Yes?
capable of handling different tasks depending on the asteroid's composition and the desired resources.
Exactly. And we can't forget about the less glamorous but essential components like conveyor belts and hoppers.
Conveyor belts and hoppers in space.
Crucial for moving and storing the excavated material in a microgravity environment.
It's amazing how much thought and planning goes into every single detail of this operation.
It really is.
But with all this innovation, it's got to be smooth sailing from here, right?
Well, not quite.
Oh,
What's the problem?
while these advancements are remarkable, there are still significant challenges to overcome.
Okay, what kind of roadblocks are we talking about?
You
What
know-
are the things that keep space mining engineers up at night?
One of the biggest challenges is tool longevity.
Toll longevity.
The abrasive nature of space dust and the harsh conditions of space can quickly wear down even the toughest equipment.
So it's a constant battle against wear and tear.
Yeah.
Trying to develop materials and designs that can withstand those extreme conditions.
Okay.
Makes sense. What else?
Another major hurdle is dust mitigation.
Dust mitigation. Those pesky fine particles of regolith have a knack for getting everywhere, clogging up sensitive machinery.
Right, like a constant layer of cosmic dust covering everything.
Exactly. It's a constant headache for engineers.
I bet.
And they're working on innovative solutions to minimize dust interference.
Okay.
But these are just two of many challenges.
I can imagine.
As we push further into this frontier,
Huh?
new obstacles will inevitably arise,
Of course.
demanding even more creative solutions.
It sounds like asteroid mining is a constant game of innovation, pushing the boundaries of what's possible.
Mm-hmm.
What are some of the more out there futuristic ideas being explored?
Well, one fascinating area of research is bio-inspired systems.
Bio-inspired systems.
Imagine taking design cues from nature's expert diggers,
Like what?
creatures like ants or moles,
Oh, wow.
and applying those principles to space mining robots.
Whoa, robots that dig like ants. Now that's a visual I wasn't expecting.
It's pretty cool.
What else?
Another mind-blowing concept is in situ tool manufacturing.
In situ tool manufacture.
Picture this. 3D printing your tools right there on the asteroid using locally sourced materials.
So no need to haul all your equipment from Earth.
Exactly.
That would be a game changer.
It would.
What other wild ideas are on the horizon?
There's the idea of integrated excavation processing units,
Integrated excavation processing units.
combining digging and resource extraction into one streamlined system.
Ah, so a one-stop shop for space mining. It sounds like the possibilities are truly endless.
They are. And as we delve deeper into this field, we're not just uncovering resources, we're uncovering a whole new way of thinking about our place in the universe.
That's a great point. It's not just about the what of asteroid mining, but the why. And that brings us to the heart of the matter. Why are we so fascinated by these chunks of rock hurtling through space? What makes them so valuable? We'll explore those questions right after a quick break. Stay with us. So welcome back, deep divers.
It's good to be back.
Before the break, we left off wondering why asteroids have captured our imaginations. Yeah. What is it about these chunks of rock just kind of floating through space?
Right.
What makes them so valuable?
It's about what's inside those rocks.
Okay.
Asteroids are like cosmic treasure chests.
Treasure chests.
Filled with valuable resources.
Yeah.
Water, precious metals.
Okay.
Even platinum group metals that are super rare here on Earth.
So we're talking about a potential source of raw materials for like everything.
Yeah.
Electronics to jewelry.
That's part of it, but the real game changer is water.
Water. I thought we were talking about mining asteroids, not setting up intergalactic swimming pools.
It might sound surprising,
Yeah.
but water is one of the most sought-after resources in space.
Okay.
And the reason why is pretty amazing. You see, water can be broken down into its basic components.
Which are?
Hydrogen and oxygen.
Wait a minute. Hydrogen and oxygen?
Yeah.
Those are the ingredients for rocket fuel.
Exactly.
Are you telling me we could create rocket fuel in space?
Imagine instead of planning missions based on limited fuel from Earth, you could refuel in space. That opens up the entire solar system for exploration.
Really?
Even colonization.
It's like finding a cosmic gas station. Suddenly those long-haul space journeys don't seem so daunting.
It's a game changer for sure. And that's not all.
There's more.
Asteroids could also provide the building materials for future space habitats and infrastructure.
So we're not just talking about fuel, but the actual construction materials to build in space.
Exactly. Asteroids could become the resource hubs that enable us to establish a more permanent presence beyond Earth.
So it's starting to sound like asteroid mining isn't just about the resources themselves,
Right.
but the doors they open to a whole new era of space exploration.
It's about creating a sustainable future for humanity in space. One where we're not limited by what we can carry with us from Earth.
That's a really cool thought.
But of course, with any new frontier, there are bound to be challenges.
Like what?
Not just the technical ones we've discussed, but ethical considerations as well.
That's a good point. Is it a free-for-all out there? Who gets to claim these asteroids and their resources?
The legal and ethical framework surrounding asteroid mining is still evolving.
It's evolving.
There are international treaties in place,
Right.
like the Outer Space Treaty of 1967, which prohibits national appropriation of celestial bodies.
So no one can own the moon.
Right, but it doesn't explicitly address resource extraction.
So there's some gray area there.
Yeah.
It sounds like a potential recipe for conflict as more nations and private companies set their sights on these celestial treasures.
It's a complex issue with many different perspectives.
Like what?
Some argue that asteroids should be treated as a global commons,
Okay.
with resources shared for the benefit of all humankind.
Uh-huh.
Others believe that private companies should have the right to claim and mine them,
Right.
driving innovation and investment.
So it's almost like a cosmic gold rush with everyone vying for a piece of the action. But instead of gold,
Right?
it's water platinum and the very building blocks of our future in space.
It's a fascinating time to be following this field. As the technology for asteroid mining advances, these debates will only intensify, demanding careful consideration of the ethical implications.
It sounds like the future of asteroid mining isn't just about developing the right tools,
Right.
but establishing the right principles for responsible exploration and resource management.
Absolutely. And that brings us to another crucial aspect of responsible asteroid mining, ensuring the long-term sustainability of these celestial bodies.
Okay.
We've talked about extracting resources, but what about the impact on the asteroids themselves?
That's a good question. Are we talking about stripping these asteroids bare or leaving behind a trail of cosmic debris?
The concept of responsible asteroid mining is paramount.
Okay.
It's not about grabbing what we can and moving on.
Right.
It's about minimizing our impact and ensuring that our activities are sustainable,
Uh-huh.
that we don't irrevocably damage these celestial bodies.
So how do you go about mining an asteroid responsibly? What does that look like in practice?
There are several key considerations. One is resource selection.
Okay.
Rather than targeting every asteroid in sight,
Right.
we need to carefully choose those most abundant in the resources we need,
Okay.
those least likely to be disrupted by our activities.
So it's like choosing the right spot to plant a garden, making sure you're not disrupting the existing ecosystem.
Precisely. We need to be mindful of the delicate balance of these celestial environments. Another crucial aspect is minimizing waste.
So no dumping space junk in our wake.
Exactly. The goal is to develop closed-loop systems where waste materials are recycled or repurposed,
Okay.
minimizing the impact on the surrounding space environment.
That sounds challenging, but essential, given the delicate nature of space.
It is. And then there's the development of low-impact extraction techniques.
So we're not just talking about blasting asteroids apart.
Absolutely not. We need to refine our methods, ensuring they are as precise and minimally disruptive as possible.
Okay.
Remember those specialized tools and techniques we talked about earlier? They're not just about efficiency, but about minimizing our footprint on these celestial bodies.
So it's about moving beyond the mentality of conquering space and embracing a more responsible approach.
Yeah.
One that recognizes the interconnectedness of all things, even in the vast expanse of the cosmos.
Well said. It's about becoming stewards of these incredible celestial bodies,
Okay.
ensuring that future generations can continue to explore and learn from them.
That's a powerful thought. As we venture further into space, it's crucial to balance our ambition with a deep respect for the environments we're exploring.
It's a delicate balance, but one that's essential for the long-term sustainability of space exploration. After all, we're not just mining resources, we're shaping the future of humanity's relationship with the cosmos.
That's a profound statement.
Mhm.
And it leads to another fascinating question. What role might we play in this incredible journey? What kind of future do we want to create in space? We'll delve into those questions and more right after the break. Don't go anywhere. So welcome back, deep divers. We've been on quite a journey today, from those first mind-boggling concepts of digging on asteroids
It has been quite a journey.
to the larger questions of responsible resource management,
Absolutely.
and even our philosophy towards space exploration.
Yeah.
We've talked about so much already.
We have.
Robotic space spiders, cosmic slushies,
Uh-huh.
even the potential for 3D printing tools right there on an asteroid.
It's amazing.
But before we wrap up, I wanted to touch on one more aspect
Okay.
that I think is crucial to this whole conversation.
I'm intrigued. What's on your mind?
Well, we've talked a lot about the technical and ethical challenges.
Right.
But what about the human element? What kind of skills and expertise
Yeah.
will be needed for this new era of space mining?
That's a great question.
Are we talking about a whole new generation of astronaut miners?
It's certainly not your typical mining job.
Right.
We're not just talking about digging holes.
No.
We're talking about operating complex machinery in a harsh and unforgiving environment, millions of miles from Earth.
Millions of miles from Earth. It sounds like a job for a special breed of individual. Someone who's not only technically skilled,
Yes.
also incredibly adaptable, resourceful,
Yes.
and maybe even a little bit adventurous.
Exactly. We'll need engineers who can design and build robots that can operate autonomously.
Okay.
Geologists who can analyze asteroid composition and identify valuable resources, and even space architects who can design and construct habitats and infrastructure using those resources.
So we're not just talking about miners. We're talking about a whole ecosystem of experts from diverse fields
Right.
working together to make this vision a reality.
Precisely. It's a truly interdisciplinary endeavor,
Yeah.
one that will require collaboration and innovation on a scale we've never seen before.
It's exciting to think about the kind of talent and expertise that will be needed to make this happen.
Yeah.
Are there already programs or initiatives in place
Oh, yeah.
to train the next generation of space miners?
Absolutely. Universities and research institutions are developing specialized programs in space resources, planetary science, and even space law to prepare students for the challenges and opportunities of this burgeoning field.
It sounds like there's a real sense of momentum building a recognition that this isn't just science fiction anymore, but a very real, intangible future.
It is. And it's not just about the jobs and economic opportunities.
Right.
It's about pushing the boundaries of human knowledge and understanding.
It's about that age-old human drive to explore, to discover, to
Yeah.
venture beyond the familiar and into the unknown.
Exactly. Asteroid mining isn't just about extracting resources.
Yeah.
It's about expanding our horizons, both literally and figuratively.
It's about redefining what's possible and inspiring future generations to dream big and reach for the stars.
It's about recognizing that our journey into space is just beginning, and that the future holds incredible possibilities for those who dare to dream and explore.
Well said. Well, deep divers, we've covered a lot of ground today.
We have.
From the nitty-gritty of excavation techniques to the broader implications for humanity's future in space.
Absolutely.
We've explored the challenges, the opportunities, and the ethical considerations of this incredible endeavor. And as we wrap up our deep dive, I hope you're left with a sense of wonder and excitement for what the future holds.
I think we all are. Because the journey to the stars is a journey we take together.
It is.
And the discoveries we make along the way will shape the destiny of humankind.
So keep looking up at those stars, deep divers. And remember, the future of space exploration is in our hands.
It is.
Let's make it a future worthy of the boundless possibilities that await us.